Hi everyone, thanks for tuning in to our service learning video. In this presentation, we are going to talk about one of the big topics from our separation processes course, liquid extraction or LLE. Before we dive into the topic, here is a quick overview of what we will be covering in this video. We will start with the basics, the introduction and objective, then move into how LLE works, why it is important, and where it is applied. We will also look at its impact and finally wrap up with a summary and conclusion. Objectives are pretty straightforward. First, we will introduce what the liquid extraction is. Then, we will explain how it works with some simple examples. And finally, we will show why it is important, where it is applied, and also the impact it has in real life. Liquid extraction, or LLE, is a way to separate a solid using two liquids that don't mix, like oil and water. The idea is simple. The solid will move from one liquid into another depending on how well it dissolves. The liquid that grabs the solid is called the extract, while the leftover liquid with most of the solid gone is called the raffinate. It all comes down to the solubility and how the solid prefers one liquid over the other. Liquid extraction, or LLE, works because some compounds like one liquid over the other. That preference makes it possible for them to separate. We usually use LLE when distillation is not practical. Maybe it is way too expensive, or maybe the compound is heat sensitive. In industry, we use LLE for things such as removing acetic acid from water, isolating penicillin, and even extracting metals such as copper and uranium. And how about everyday life examples? You can think about boiling coffee, cooking curry, and also how water and oil can be naturally separated. They are all using the similar principle, but only in a different scale.
Let's walk through the basic step of liquid extraction, a process used to separate compounds using two immiscible liquids such as oil and water. We begin with a mixture that contains oil, water, and a solute. These liquids do not mix, and the solute is looking for the liquid where it dissolves the best. Next, we stir the mixture. This allows the solid to move freely between the two layers, searching for the one where it is more soluble. After mixing, we let the system settle. The liquid separates back into distinct layers, each with a different concentration of solute. Finally, we isolate the layers. The extract contains the solute solid-rich liquid, while the raffinate is the leftover layers with less solute. This simple sequence, mixing, settling, and separating, is the foundation of liquid extraction. It is used in chemistry labs, environmental engineering, and even food science. Now, let's look at a simple everyday example to see liquid extraction in action. In this beaker, we start with cooking oil on top and dye water mixed into it. At first, the color water seems to sit inside the oil layer, but watch closely. Over time, the dye water begins to move downward into the bottom layer. This happens because water molecules prefer to join the water phase rather than stay in oil. The two liquids are immiscible, so they separate into distinct layers, and the dye water migrates into the one where it is most soluble. What we see here is the same principles as in the lab. Solids naturally transfer into the liquid where they dissolve best. The oil layer remains mostly clear while the water layer collects the dye. This simple kitchen demonstration mirrors the extract and raffinate process we discussed earlier.
Liquid extraction goes beyond the laboratory. Let's see how it is applied across different industries to achieve safer, cleaner, and more effective processes. First, in pharmaceuticals, liquid extraction is vital for medicine production. It allows the isolation of vitamins like A and B from natural sources, and the extraction of antibiotics and during medicines are pure ineffective. Without this process, many life-saving drugs will be harder to produce. Next, in food and beverage industry, extraction improves what we consume daily. It is used in a decaffeination of coffee and tea, giving us caffeine-free options, and in the extraction of natural flavors like vanilla or citrus oils, which are added back into food and drinks, which make the products more healthier. In environmental applications, extraction helps protect water resources. It is used in wastewater treatment, removing harmful chemicals, and in groundwater purification, pulling out toxic materials that seep into underground water. These processes safeguard community health and ensure cleaner water supply. In chemical manufacturing, extraction is essential for isolating valuable compounds. It enables the separation of organic acids used in food preservatives and industrial processes, and the recovery of aromatics, which are key ingredients in plastics, fuels, and perfumes. This makes production more efficient and sustainable. Finally, in agriculture, extraction refines chemicals that protect crops. It supports the purification of pesticides, making them effective yet safe, and the separation of herbicides, which target weeds without harming crops. This contributes to higher yields and sustainable farming practices.
Liquid extraction is important because some mixtures cannot be separated using distillation. When substances have very close boiling points or are sensitive to heat, heating may damage the product. In such cases, liquid extraction provides a more suitable and effective separation method. This process also plays an important role in protecting health and food safety. It is widely used to purify medicines, remove caffeine from beverages, and refine cooking oils and vitamins, ensuring that these products are safe for human consumption. In terms of environmental protection, a liquid extraction helps remove harmful chemicals and pollutants from wastewater before it released into the environment. This supports cleaner water resources and helps industry meet environmental regulations. From an economic perspective, liquid extraction is energy efficient. It requires less energy compared to heat-based separation methods, which reduce operating costs and improves resource recovery in industrial processes. The use of liquid extraction creates several important impacts on how the environment, the economy, the community, and sustainability. First, the health impacts of liquid extraction is significant. This process helps produce safer medicines, purify vitamins, and cleaner food products by removing unwanted substances. As a result, it reduces health risks and improves the safety of products consumed by the public. Second, the environmental impact of liquid extraction is its ability to remove pollutants from water. By separating harmful chemicals from wastewater, this process helps protect rivers, ecosystem, and water resources. Third, the economic impact of liquid extraction is related to efficiency because it is used less energy compared to heat-based separation methods. Industries can reduce operating costs and minimize material waste. Next, the community impact of liquid extraction can be seen in daily life. Cleaner water, safer food, and reduced pollution contribute to healthier living environments for communities. The sustainability impact of liquid extraction lies in its support for environmentally responsible engineering. By improving efficiency and reducing environmental harm, this process helps promote long-term sustainability and responsible use for resources.
To wrap up, liquid extraction or LLE helps separate compounds based on their solubility. It is great for recovering valuable materials, especially when heat is a concern. In industry, it leads to safer product, cleaner ecosystem, and finally a better energy use.
Here is my challenge for you. Let's keep learning and applying science to build a cleaner, healthier, and future together. Notice extraction in daily life, like when you brew tea or coffee. Appreciate how this process safeguards our health and environment. And most importantly, stay curious about how engineering solutions make everyday living safer and more sustainable. Science isn't just in the lab. It is in our kitchens, our communities, and our future. Let's keep celebrating, share it, and keep exploring together.